Hello friends, hoping you are doing great. This session is in continuation of what is singleton pattern and how it works. I'll go through all the fine points and explain each and everything bit by bit in detail. So let's start now. Just to recap what we covered in part 1, we discussed what is singleton pattern and how it can be created. I am reiterating my statement. It is very simple yet very complex at the same time. And today I will prove my point. We will dive into some complexities and will discuss the situation where singleton concept may be violated. We will cover each scenario in detail. So, see here the scenarios where it can violate the singleton concept. First scenario is multi-threading environment. So let's go over Eclipse. Here we learned in previous session how to create singleton using lazy initialization. But this method also has its own drawback. Suppose there are two threads, T1 and T2. Both comes to create instance here, and execute instance is equal to null. Now both threads have identified instance variable to null. Thus assume they must create an instance. This sequentially go in and create the instance. At the end, we have two instances in our application. So to prove our points, let's go through example. We will implement here multi-threading sample program for singleton demo. So first thing we will do here, we will extend either thread class or implement runnable. So here I am implementing runnable class, runnable interface. It is saying to give body a run method. I done implemented method. Here it is added. In the run block, I will create singleton demo instance s1 equal to singleton demo dot get instance, and I'll print here hash code of the reference variable. Take it like s dot hash code and hash code of s. I am printing here hash code of every instance within run method. Now we will go in main method and we'll create multiple threads to demonstrate how singleton can be violated in multi-threading environment. So here I am removing this part of the code and executor service equal to executors dot get. We will see here methods. So right now we are creating new fixed thread pool of suppose 15 pool of 15 threads. Here imported executor service from java.util concurrent package, and after that we submitted the thread runnable task, because so we have runnable class new singleton demo here. After that I shut down the executor framework after doing the task. So now here we have pool of 15 threads. Let's submit multiple thread. We can do it through loop also, but here for simplicity purpose I'm just writing down few times. Yeah. So see here, first step we implement runnable interface, and below we give body to the run method and pretend here the hash code of every object. And in main method we created instance of executor service and submitted our runnable object. And once task done, I have shut down that service. So let's run and see what the result will come. We are getting same hash code for every runnable object. Execute it few times and see if we are able to generate some different hash code or not. Yes, same hash code, same hash code. Yeah. See, after executing few times, we didn't get different hash code for the objects, but ultimately we got success. In one of the execution, we got different hash code for one of the object, and for all others object same hash code we received. So here, singleton pattern is get violated because we got two hash code of singleton demo instance for this program. So we will discuss in next video how we will provide resolution to overcome this problem. But before we'll discuss some other scenario as well, that how it gets violated in other scenario as well. So let's go through some other scenarios here. Multi-threading, we saw here that it got generated, we got different hash code for the threads. Next is reflection. Through reflection also we can get different hash code for same singleton instance, and it can cause to destroy a singleton property of singleton class while loading the class at runtime and modifying the constructor. So let's see how we can modify the constructor at runtime while using reflection. So make the changes as earlier. Lazy initialization. Yeah, so this was the initial program where we instantiated this singleton demo instance by null, and based on instance is null or null, singleton instances get created, and after that we compare hash code. So how singleton pattern gets violated in reflection, we are going to demonstrate that. So here let's make changes. Here we will create two instances of the singleton demo class by calling getInstance method, and now we will use reflection. So let's here after that we will load this class singleton demo at runtime class.forName, and we provide name of the class in double quote. Let's it is saying so to surround with try catch or add throw declaration, so I am adding here throws exception. Now here we received class object reference variable, and through it we will create constructor java.lang.effect class dot. Here we can use different method, get constructor and get declared the constructor. So here we will go and use get declared constructors. It will return as array of constructors. Let's take first constructor, and after that we receive private constructor reference variable. Now we'll modify the private attribute of the constructor to make it accessible. So here set accessible and pass as true. And now we'll call the constructor of this singleton demo class. Here the constructor but new instance. For now we pass here as null. Now we have to cast this. So let's cast by singleton demo class. Now let's execute and see the result if we receive same hash code or different hash code. Now let's print hash code of object created by this reflection. Let's print it. Let's execute and see the result. Here we can see for S1 and S2 hash code is same, but the object that we created through reflection by modifying the constructor accessibility on this line private constructor dot new instance. For not singleton difference variable we are getting different hash code. So here rule of singleton norms is get violated. Let's see other scenario. Next scenario is serialization and deserialization. So serialization can also be cause breakage of singleton property of singleton classes, and singleton is used to serialization is used to convert an object a byte stream and save into file or send over a network. Suppose you serialize an object of a singleton class, then if you deserialize that object, it will create a new instance and hence break the singleton pattern. So see through this one example. Let's remove this part of the code and see how it will be get violated in case of serialization and deserialization. So first thing we will do, we will implement here serializable interface. It's not required. And in second step, we'll first serialize S2 object, and after that deserialize that object, and we will see what is difference. So here object output string plus out equal to object output string new file output string. Here we are giving path s2.sci. So here now it is get removed, error is get removed. Now we will serialize object by using a write method of object output string. So let's print some message here. Now object is serialized. Now we will try to deserialize the object. We will use object input string for deserializing the object. New file input string, and here we will give path, same path as we provided in serialization process. Put it in double quote. Now read the object. So object and say it like singleton demo, not singleton. Cast it. After the serialization, I have printed out the hash code of the deserialized object here. So let's check out whether hash code of S1, S2 and not singleton, the object we created using serialization or deserialization process, are same or different. Let's check out. Yeah, see here. For hash code of S1 and S2, where we are calling get instance method of singleton demo class, we are getting same hash code. But for the object that we are creating through deserialization process, not singleton reference variable, we are getting different hash code. Hence, here also rule of singleton instances get violated in case of singleton serialization and deserialization. So that's all for now. Please keep on writing your queries and comments. In next video, we will cover rest of the parts: cloning, multiple singleton, distributed environment, singleton loaded by multiple class loader, destroyed and then reloaded by garbage collector, and multiple singleton created by a factory. So from the point 4 to 8 point we will cover in next part of video. So keep watching. Thank you.